Hey guys, it's Mr. Bosher. So today I'm going to show you the last idea that solving systems can kind of throw at you. So we talked about how we can solve them with the graph. I showed you guys, how they can make it harder by making you having to convert the equations to self-intercept form. I showed you how they can make it harder by making different types of solutions, right? Instead of just being one answer, you could technically get no solution if they're parallel, or you could get an infinite solution if the lines are the same. Okay, so that's all of that stuff covered. There's one last thing they can throw at you though, and if you notice, there's no equations on here. Yeah, the last thing that they can make you do is they're going to give you a word problem, and they're going to combine that writing systems idea that we talked about while I was still there, and make you then solve the system that you end up writing. Okay, so this is actually a star question. I think one example is enough because at this point you should know how to solve and you should know how to write them. So we're just kind of combining the skills into one problem. I think you guys get the idea of what we're going to do. Okay, so let's run through one real fast. So the main thing that is different, and I'll figure out where I can write it. I'll probably just put it right here by the answer choices for now. The main thing that is different about these problems compared to before is that we need to make sure we define our variables. Okay, and what do I mean by that? Well, if you notice, they didn't give you equations, and they didn't tell you what should be x and what should be y, or what variables to even use. Okay, so as I read through this problem and write equations, we need to make sure that we're keeping track of what each variable represents. So, for example, let's say I consider this whole first line here to be my first equation, because it says 2 customers purchase coffee and donuts at a coffee shop. Each cup of coffee costs the same amount, and each donut costs the same amount. The first customer paid $4.90 for 1 cup of coffee and 2 donuts. The second customer paid $8.60 for 2 cups of coffee and 3 donuts. What is the cost of 1 cup of coffee? All right, so remember that this sounds like a system question because it sounds like I have 2 equations, one for the first customer and then one for the second customer. All right, so let's focus on the first customer for now, and how would we write that equation? Well, remember when we pay for things with a final cost, this acts like a total amount. So that means that I'm going to expect to kind of combine my numbers here. So I'm going to be adding them together, right? So if you remember that, it means I'm going to get standard form. So it's going to look like x and y are going to be added together to some value, which we now know is 490, or the total. So if I start writing its equation, I know it's going to be equal to 490. And some of you have probably already caught on. It's like, well, how did I get that 490? Well, simple. I bought 1 cup of coffee and 2 donuts. So you might be tempted to say 1C plus 2D equals 490, right? 1 cup of coffee plus 2 donuts equals 490. Keep it simple. And that's perfect. The only issue with this is that, remember, we're going to eventually solve this. And when we solve things, we use Desmos. And Desmos doesn't know what C and D are, right? The only things that Desmos knows is X and Y. So, while you can write your equations with letters that make more sense, like C and D for coffee and donuts, when you give that to Desmos, it's going to have no clue what you're talking about, and it won't be able to graph it. So what I recommend is, when you start writing these equations, if you want to start it with the letters, that's fine, but you should go back and replace them. So when it says 1 cup of coffee, maybe coffee in this problem is going to be X. When I say 2 donuts, maybe donuts, I change to Y. And that's what I mean by define variables. You want to make a mental note, or even just write it on your paper like, hey, I've decided that this thing is X and this other thing is Y. Okay? So I might How would I do that if I were you? If you were writing on the actual screen like I am here, I'd probably do it like this. I'm going to get rid of all this that I wrote up here. And I'm just going to remind myself, like, oh yeah, coffees I called X, donuts I called Y, and that way they're kind of together. Yeah. Okay, so hopefully that makes sense on what I'm saying there. And the reason that's important, I'll kind of jump ahead on like why it's important. Notice that the problem is asking for the cost of 1 cup of coffee. So if you're not careful with which one is X and Y, you could do all the work, do all of it right, and then at the final answer, you pick the wrong variable to read and then put the wrong answer. Okay, so that's why it's important. So now that I've decided that coffee is my X value, I know that at the very end of this problem, it wants to know what is the X value, right? Let's see if I can make a better question mark there. That's what it wants to know. If it said, for example, what is the cost of 1 donut? Well, then I would need to look at the Y value at the end of all my work rather than the X value. Okay? So hopefully that made sense. If not, I'll try to explain it at the end on what happened. But basically, you just need to make a note and a check, like, which one am I calling X, which one am I calling Y? Okay, just so that all of your equations make sense and Desmos can actually graph them for you. That's the quick explanation. All right, let's do the second customer now. Second customer pays $8.60. That, again, sounds like a total, right? A final price. So I know I'm going to be equal to $8.60 for 2 cups of coffee and 3 donuts. Remember, coffee we called X and donuts we called Y. So keep it simple. 2X is my 2 cups of coffee. 3Y is my 3 donuts. Okay? So I have my 2 equations. But remember, to solve these, we need to go to Desmos. And to go to Desmos, well, these need to be in slope-intercept form, or y equals mx plus b. So now I got to convert these. So let's work on the first equation. 1x plus 2y equals 490. So first customer's equation was 1x plus 2y equals 490. And you might already start to see why these are the most annoying problems, probably in the whole year, because you're basically doing 2 really long problems in a run, right? You got to write the system, and then you got to solve the system. It's pretty brutal, but we'll see how we do. Okay, let's convert this. So remember, converting, you want to get the y value by itself. Easiest way to do that, get rid of the x's first, and then the number in front of y. So to get rid of 1x, well, I take its opposite, which is minus 1x, and I do that on both sides. They cancel out, leaving me with 2y equals the 490, and I could say minus 1x, or I can just say minus x, right? Because 1x is the same as x. So I'm going to just do minus x so it's cleaner. And then I remove the number in front of y. So I could say divide by 2, divide by 2, divide by 2. So I get y equals whatever 490 over 2 is. But remember, I'm going to put my answer in Desmos anyway. So I could simplify this, or I could just type this into Desmos like this, right? As long as I know that I wanted it to divide by 2, I can type that into Desmos, and then it knows how to get the answer from there. And then on this side, I have minus x over 2. So this is what I'm going to type in for my first equation. Simple as that. Like I said, if you like things simplified, you could ask Desmos for the first fraction. But as you'll see when I type this in, it's still going to give me the line because I still followed all my steps correctly, right? I got rid of the x's, and then I divided the 2 away. So this should be perfectly fine. All right, second equation we said was 2x plus 3y. 3y, and what was it equal to? 860. Okay, 860. Same steps as before. Get rid of the x's, then divide away the number in front of y. So 2x, how do I get rid of that? We do its opposite, which is minus 2x instead of positive. Cross those out. 3y equals 860 minus 2x. I'm just copying what it says there. And then lastly, divide away the 3 so that it cancels out. Do that on both sides. So I have y equals 860 divided by 3 minus 2x divided by 3. Again, I could check what this 860 divided by 3 is in Desmos, but if I'm going to type it in already, I might as well just type in my whole answer into Desmos and have it do the line. Okay, so this is perfectly fine to type in because you're still following all the right steps. Get rid of x, divide away the number. All right, so let's do that now. And then remember, it wants, let me do it like in yellow, it wants 1 cup of coffee. Remember, coffee is the x value. So when I go and I get both the x and y value in Desmos, hopefully, I only care about the x value here, okay? All right, let's do that. 490 over 2 minus x over 2. Oops. All right, here we go. Y equals 490 divided by 2 minus x divided by 2. And, okay, cool. I just had to zoom out a little bit. There we go. So there's our first line. Our second line said, this is the one in red that I'm looking at, y equals 860 divided by 3, or 8.60 divided by 3 minus 2x over 3. Y equals 8.60 divided by 3, and I already forgot what I said, minus 2x over 3, minus 2x divided by 3. All right, so there's my 2 lines, and remember, where they intersect is my answer, so I'm going to zoom in on that, and I get this, 2.5 and 1.2. 2.5 and 1.2, so I'll write that over. Oh, where do I have room? I'll put it over here, I guess, in this little section I have left. So, I had 2.5 and 1.2. But remember, it wanted the coffee, which we decided at the beginning, to just call x. So between these two answers, because if you notice, they are both answers that are possible, we say it specifically asked for the coffee, which we called our x value. So we take the x value of the coordinate point, not the y value. Okay, so we get 2.5. So final answer would be 2.5. Okay, so hopefully that all made sense. I know it's kind of a mess when I make them just on the screen like this, but hopefully you get the idea. Basically, you have to write your own equations with what we learned while I was still there, and then solve the equations with what I've shown you through the video lessons. The one thing that students mistake is that they don't double check which variable they want you to get, right? So in this instance, it said coffee, but if, and as a hypothetical, if they switch this to what's the cost of 1 donut, well then remember, that would now be the y value instead if they said donut, and we found out that this was the y value, the 120. Okay, so this would be the 1 donut answer. This is the 1 coffee answer. Okay, and they do that on purpose with a lot of these questions to see if you're paying attention. And they will switch up if they want the x or the y. So be careful of that when you try it yourselves, because your assignment today is just going to be a few star questions just to kind of like see how you guys would do on those. So just always double check that at the end, like, hey, which one do they actually want for this problem, the x or y? All right, well, I hope that was helpful. It's just kind of combining the two things, like I said. If you have any questions, let me know, and good luck.